Hello there. This is section 4.8, Applications of Polynomials, Equations, and Functions. Let's begin with the definition of a quadratic equation. It's a second-degree polynomial in one variable, often called the quadratic equation. So what we mean by second degree, it means that the highest exponent is a 2. Now, next we have our most helpful definition, and that is the principle of zero products. For any real number, a and b, if a times b equals 0, then a equals 0 or b equals 0 or both. If a equals 0 or b equals 0, then when we multiply them, a times b is 0, right? So like if I have 2 times 0, we know it's 0. And really, to get 0 as an answer, they don't both need to be 0, only one of them needs to be 0. Does it matter which one it is? No, it can be, like, if we're using our definition, it can be A or B or both. They can both be 0 or just one of them. But what makes it different is when we multiply them, our answer is 0. And that's what that zero principle is talking about. So let's take a look at this example. Example 1. We want to solve x squared minus x equals 6. Well, we haven't done a problem like this. So how would we approach it? Well, we can use our principle of zero products. And we can also factor. So that we can create two factors and then set them equal to 0. But just like we said, we need to set them equal to 0. So let's set this equal to 0. So to make it a 0, let's go ahead and subtract 6 to both sides. 6 minus 6 is 0. We're left with x squared minus x minus 6 is equal to 0. Okay, so if we wish to use our principle of zero products, then I need to go ahead and create two products. So can we factor this? Let's see. Are there numbers that multiply to be negative 6 that add to be negative 1? Yeah, 3 and 2. I can make a 3 a negative, so that 3 times 2 is negative 6, and 3 plus 2 is negative 1. So this factors to be x minus 3 and x plus 2 equals 0. Now we can apply our new principle. If each factor, when we multiply them, equals 0, then both of them are 0 or 1. So let's go ahead and set both of them equal to 0. X minus 3 equals 0, or x plus 2 equals 0. Let's go ahead and solve. So let's solve to get x by itself. So let's go ahead and add 3 to both sides to get 0 by itself, so that we have x is equal to 3. Let's subtract 2 to both sides. We get x is equal to negative 2. That's our answer. That's so impressive. We've come so far. So again, we use two ideas, factoring and the principle of zero products. All right, so here we have some helpful steps. To solve an equation using the principle of zero products, 1, you first want to obtain a 0 on one side of the equation. So you need that equals 0. So important. 2, factor the other side. 3, solve the resulting equation. Example 2, solve 5b squared minus 10b. So same idea. We first need to, well, we have our steps here. We first want to set it equal to 0, factor, and then solve. Okay, so let's go ahead and set it equal to 0. So I want to make that be 0, so I subtract. What we do to one side, we do to the other. So we're left with 5b squared minus 10b. And I can't combine those terms, but we can factor. So let's go ahead and factor. So I see that they have a b in common, and they can both be divided by 5. So let's factor out a 5b. If we do, we're left with b minus 10 divided by 5 is 2. b minus 2. All right, now we have our principal. We can go ahead and set each one equal to 0. 5b equals 0, and b minus 2 equals 0, and let's go ahead and solve. So here I want b to be by itself, so let's divide by 5. 5 divided by 5 is 1. We're left with b is equal to 0 divided by a number is always 0. Let's go ahead and add 2 to both sides. B is equal to 2. So these are our answers. You can say b is equal to 0 and also 2. Next example. Solve. 3x cubed minus 9x squared equals 30x. So our first rule is we first want to set it equal to 0. 2, we factor. And our third step was solve. So let's go ahead and do that. So our first step is to set it equal to 0. So let's go ahead and move that 30. Minus 30x is 0, minus 30x. So that we have 3x cubed minus 9x squared minus 30x is equal to 0. Okay, let's go ahead and factor. Well, we want to factor the greatest common factor, right? So I see they can both be divided by a 3, and they both have an x, so we pick the x of lowest degree. They can be factored by a 3x. So that we have x squared minus 3x minus 10. Okay, I see we have a trinomial. Can we factor that trinomial? Well, let's see. Are there numbers that multiply be negative 10 that add to be negative 3? I think 5 and 2 work, and if I make 5 my negative, that addition holds true. So that negative 5 times 2 is negative 10, and negative 5 plus 2 is negative 3. So we have so far 3x times x minus 5 times x plus 2 is equal to 0. Okay, next step, we want to go ahead and set each one equal to 0. So that we have 3x is equal to 0, x minus 5 is equal to 0, and x plus 2 is equal to 0. Okay, let's go ahead and divide. We're left with x is equal to 0, x is equal to 5, and x is equal to negative 2. So you can write them like that separately, or you can write them as one single line of answer. So our answer is 0, 5, and negative 2. Both are fine. Next example. Given that f of x is equal to 3x squared minus 4x, find all values of x for which f of x equals 4. Okay, f of x is equal to 4, so they're the same thing. So that means I can replace that f of x with the 4. And then our goal is to solve for x. So far what we have is 4 is equal to our question, which is 3x squared minus 4x. Okay, this looks like what we have been doing this entire section. Let's go ahead and set it equal to 0. So let's subtract 4, and we have 0 is equal to 3x squared minus 4x minus 4. Okay, let's see if we can factor. So is there numbers? We have A, B, C. So numbers that multiply be negative 12 that add to be negative 4. So I think 6 and 2 will do the trick. If I make 6 a negative, then negative 6 times positive 2 is negative 12. But And also, negative 6 plus 2 is negative 4. So that checks out. We want to replace our middle term so that we have 3x squared minus 6x plus 2x minus 4 is equal to 0. Let's go ahead and group our first two and our last two. In our first two terms, we can factor out a 3 and a x, so that we're left with x. Negative 6 divided by 3 is negative 2. On the last two, they have a 2 in common, so let's divide out a 2. We have x, and negative 4 divided by 2 is 2. Okay, we see we have the same thing in the parentheses, so we can factor that out, so that we're left with x minus 2 times 3x plus 2. And all of this is equal to 0. So let's go ahead and set each factor equal to 0, so that I have x minus 2 equals 0, and 3x plus 2 is equal to 0. Let's go ahead and solve for x. Let's go ahead and add 2, x is equal to 2. Minus 2, 3x is equal to negative 2. Divided by 3, x is equal to negative 2 over 3. So my answer is negative 2 over 3 and 2. Not so bad, right? I think this part kind of threw me off at first when I read it, but then I thought, okay, well, it's just telling me what to replace it with, right? And that was at f of x. Next example, example 5. Find the domain of f of x equals x minus 2 divided by x squared plus 2x minus 15. Well, let's recall what domain means. This means what values of x work. Now, for the most part, we've worked with lines, and lines have a domain of all real numbers. I can plug in anything for x. What we have here is a rational function, and you'll see a lot more of this in your next class. Now, the problem here is that when I have a fraction, I can't divide by 0. It gives me an undefined point in our function. So the problem in this case is that denominator, because depending on what x is equal, I can get a 0. So our goal is to find out when it's not equal to 0. So to do so, let's go ahead and take our denominator and set it equal to 0. So I have x squared plus 2x minus 15 is equal to 0. Let's go ahead and solve. Okay, so what numbers multiply to be negative 15, but add up to be 2? 5 and 3 work. I can make 3 negative, so that 5 plus negative 3 is 2. Okay, so we have an x squared. This factors to be x plus 5 times x minus 3 is equal to 0. So we set each one equal to 0. We get x is negative 5, and we get x is equal to 3. So we have these two answers, and what's the problem? The problem is whenever x is those numbers, I get an undefined value in the bottom. I get a 0 in the bottom. So those are the only 2 points that give us any trouble in our function. So our domain, our answer to this question, our domain is all real numbers except -5 and -3. Oh, +3, not -3. Okay, now we need to learn how to write it in both interval and set builder for the sake of being prepared for the next class. Okay, when we have these values, I always need to draw a number line because it really helps me keep track of what we're working with. I have a -5 and a 3, and we're saying it can be any number, just not those two. But anything in between and anything going on forever and ever is fine. So in interval notation, my answer would be from -infinity, and then I have to take a break at -5. I pick up from -5 and stop at 3, and then pick up at 3 and continue on forever in the positive side to infinity. Step builder. We have x such that, and then we have to write our argument. So step builder would be, well, actually, when you work on your next class, you'll see mostly interval, and I think you'll see interval in your homework, so we're okay with interval. All right, that's it for section 4.8. Thank you.